Hey everybody, so we're going to be talking about geometric sequences today. It's similar to what we were doing with arithmetic. And so before we go into geometric, let's go ahead and do a quick review over arithmetic sequences. So arithmetic sequences, they're linear. Remember we used slope-intercept form, which is y equals mx plus b, to get our formula and to set it up. By definition, it's a list of numbers with a common difference from term to term. The so an example of that is 5, 7, 9, 11, and if we were to keep going, it'd be 13, 15, 17, 19, 21, 23, and so forth and so forth. The formula that we were using was a sub n equals dn plus a sub 0. Remember, d stands for the common difference. That's the letter D. And a sub 0 is your 0 term. So the only thing with arithmetic sequences was that you had to do that extra step and kind of try to figure out, okay, well, where did I start? You're not going to have to do that for geometric. Now, this looks like a lot because you're seeing it all at once, but just hold on. Now, geometric sequences right here. An example of that is 2, 6, 18, 54. What's happening each time is that you're multiplying. Instead of adding or subtracting like we were doing, we're going to be multiplying the previous term by a common ratio. Last time it was common difference. Now it's going to be common ratio. So common ratio right here, you can use the letter R. And it has to be a lowercase r. Geometric sequences, they're essentially going to be exponential, what we just talked about in the last chapter. Because you're multiplying something and you're taking it to a power right here. So make sure you've got this. Remember, a sub 1 is going to be your first term, a sub 2 is your second term, a sub 7 is your seventh term, and a sub n is your nth term or your any term. So remember that, and this is what we're going to be using right here to set up our formulas. And it's going to be a whole lot easier to set up. So here's an example of something that you would get. You've got this table, and we have to find the common ratio in order to set up our formula. This part right here is easy, a sub 1. Remember, a sub 1 means it's the first term, which is 5 in this case. So super easy. You've already got part of your equation right here. You've got it down already. So I'm going to put that in. It's not the same color, sorry. And you're going to do 5 times our R. Remember, our R value right here is the common ratio. The common ratio is what did I multiply the 5 by to get to the 10? I multiplied by 2. And that's why it's common, is because every single time I'm multiplying it by the same thing. I'm multiplying it by 2. So our common ratio here is 2. And everything else is just, you're copying it down and filling in the blanks. You just need your a sub 1, which is your first term, and your common ratio, which is 2 in this case. Sorry, I'm struggling. You do need to write this part down. That's something that doesn't change. That's where your input is going to be going. So again, we could use this for any term. So we are going to use our equation to find any term. In this case, our sixth term. When we're looking for our sixth term, that means our n value is equal to 6. So we are going to rewrite our formula for our any term and say instead of any term, we're going to find our sixth term, which is equal to a sub 1 times, and let me rewrite it like the other way. Honestly, if you put the parentheses around it, it won't hurt you. Five times 2 to the n minus 1. So now it becomes 5 times 2 to the fifth. When you're using PEMDAS, remember, it's parentheses exponent. So we're going to do this part here first. So if you're curious, we are going to be, you can use any calculator. You can use Desmos or just this calculator right here. And you're going to type in 2 to the fifth power. And you're going to use this button right here. And it tells you that it's going to be 32. So it's 5 times 32. And 5 times 32, that's a lot. But if you can do it in your head, like I just did, awesome. Don't say anything. But what you can do then is go back to your calculator and just multiply it by 5, which will get you 160. We can also do the same thing for when we're looking for the 12th term right here. So a sub 12 is equal to 5 times 2 to the n minus 1 power, which really means that it's a sub 12 is equal to 5 times 2 to the 11th power. Holy moly, I don't know that. So I'm going to really quickly go into my calculator. I'm going to clear it out. Wasn't that cool? All right, so now you're going to do 2, and it's y to the n. Some of you might have an x to the y on your calculator if you're using an Apple. Same thing. And we're taking it to the 11th power. Holy. And that's 2048. Yes, 2048, just like the game. It's a power of 2. So now we're going to do 5 times 2048. Oh my goodness. So we ain't got time to do that in my head right now. So we're going to go in. I'm going to have you do type times 5. And now you've got 10,240. And you would have that as your 12th term. Now, something that we've noticed in this example is that you are multiplying, but what can also happen here is maybe you've got a table and your numbers are going backwards. So just like with arithmetic sequences, sometimes where we would be subtracting, but it was really just adding a negative number, you're going to have the same thing here. So say I've got 100, then it's going to 50, then to 25, then to 12.5, then to 6.25. Now what's happening each time is I'm dividing it by 2. But I can't write that as my common ratio because my 2 is not my common ratio in this. We have to think about it in terms of multiplication, which means what I'm really doing is that I am going to be multiplying by 1/2. Remember, dividing by 2 is the same thing as multiplying it by 1/2. And 50 times 1/2 times 1/2. So in this case, your R would actually be 1/2 because that's what you're multiplying by. It's super important that you're thinking about what you're multiplying that last number by. And that's where you get your common ratio from. I hope this helps in terms of your arithmetic and geometric sequences. Make sure you've got this down in your notes. Stay safe, stay healthy. I love y'all. Thanks for watching.